97 questions, and before we start, a couple of things. Your exam next week, what we cover today is the last thing that's on the exam, so we have to get through it today. All right, so no ifs, ands, or buts, it's on there. I already made that up. Questions on 197, that was the previous time.
35.
Says finding expected values.
Nice.
No problem.
Yeah.
You get a good look at it.
No, I didn't really look at it.
Is that the exam?
Review.
Charles.
Oh no,
Oh.
Riley, you should have snagged one of them.
I don't know what it was.
Sorry, we're missing a few actually. The exam.
I thought it was the review, so I didn't really.
That's when I
Look
should
at
went
it.
and got the papers.
So then.
Oh, so then you would have cheated?
Yes.
So it was the exam? Oh.
I've been smart.
35 says students in a class take a quiz with 8
Have a homework.
questions. The random variable x represents the number of questions answered correctly. They want you to find the mean, the variance, the standard deviation, and the expected value, and interpret the results. What are we going to do with those numbers?
You gotta put them in the chart.
Oh, that might be the one I grabbed another one. I already turned that in.
Yeah, you should.
So on this, in your calculators, this is number 35. In your calculators, put in the x values for list 1 and the probabilities for list 2. I'm going to go to stat, edit.
Because it was with Kim. She don't want to.
That's funny. There's students.
What?
South was crazy.
Yeah, South is gonna be nuts.
Yeah, and we're at South.
If you're not enough. At the RTM, the freshman. I'm happy Dallas is driving on Saturday. It doesn't matter anyways.
We're gonna lose.
Do we also
Last time he wasn't there.
I missed the list.
And he lost the last time he was there.
He said he doesn't care anymore.
He just see how long.
He said he's coming Friday, so. If you guys.
So they want the mean, they want the variance, they want the standard deviation. And we'll talk about the other two parts in a minute. So if I put them in my calculator, I go to stat, calculate, one variable, second, whatever list you put it in, comma, and second, in the second list you put it in, hit equals. What's it tell you that the X bar is off your calculator?
So it's comma what, sorry?
Comma, then the second list, whatever the second list is.
What help if I put the numbers in right?
That's what I did wrong the first time.
Mean 5.30.
So means 5.3. Variance, they don't tell you on the calculator. Standard deviation. On the standard deviation, they only give me this one. So I'm guessing that's the one we're going to use.
Put 1.8.
1.80, something like that. How do we get the variance if we know the standard deviation?
Square it.
You just take this and you square it. So you have to type in 1.8 squared and see what that is.
3.2.
Now, part of what, we went over it last time, but it was just real quickly, or the 2 times ago, it was real quickly at the end. The expected value, don't make the expected value any harder than it is. The expected value is whatever the mean is. So the expected value this time is 5.3.
So it's always what the mean is.
Yep. So if we're looking at that, because the next part says explain this, it said students in the class take a quiz with 8 questions. The random variable represents the number of questions answered correctly. So if the mean is 5.3, that's our expected value. What's that telling us?
That everyone's gonna get 5 point or more than likely gonna get 5.3.
Okay, we expect that most get 5 questions correct. Now, that's probably not worded right because it says most. What we're expecting is that if we were looking at a graph and it had 0, 1, 2, 3, 4, 5, 6, 7, 8, we would expect that most of the scores would fall somewhere in there. Most of the number correct would fall somewhere in there. But again, the main thing here, mean, expected value are the same thing. Other questions?
That's the only part.
Are you checking the video with these?
Nah, I don't feel like looking into it. I was going to.
You just put them in as A's in, because we're on We're not gonna
Me either.
over. So let's keep my grade floating.
All right, well, we're going to cover binomial experiments. again, we gotta make sure that we get through this because there's a question on the exam that's at the very end of these notes. So binomial experiment is a probability experiment. That's what we were dealing with last time. Same kind of setup. Only it's considered a binomial if it can be reduced down to two outcomes, either a success or a failure. So, and by the end of this chapter, start of next quarter, when we start doing this again after break, you're going to have to be able to decide on the next test, am I using binomial stuff on this, or am I using the stuff that we did the first section? All right? So you got to be able to tell if it's a binomial or not. And again, if it's going to be binomial if it can be reduced to just two possible outcomes, a success and a failure. So something like if I'm rolling a die. If I just say I want to roll a die, then it won't be binomial. Because what are the possible outcomes for rolling a die?
1, 2, 3. But like a free throw would be binomial.
Now, we could make rolling a die a binomial setup by saying, we want to roll a die, but we want to roll a 4. Well, that means if we roll a 4, that's a success. And if we roll anything else, it's a failure. So we could make it that way if we wanted to reduce it down to that somehow. All right? But like a free throw would be a binomial because either you make it or you miss it. Binomial experiment, the experiment is repeated a fixed number of times. There are only two possible outcomes. So this is what makes something a binomial. The probability of a success is the same for each trial, and the random variable x counts as the number of successful trials. As you write this stuff down, shorten this up. Don't write all of this. Shorten it up somehow. The experiment, like I would probably write, it's repeated, fixed number of trials. Only two possible outcomes. Probability of success, same for each trial. Variable x stands for successful trials. That's what makes something a binomial experiment. So if we were using the free throw as an example, we were using the free throw as our experiment, the experiment's done a fixed number of times, so we might shoot 10 free throws. There's only two possible outcomes, either you make it or you miss it. The probability of a success is the same for both. If it's the same, in other words, if we're doing a free throw, we can't switch from Michael shooting a free throw about 20% to Ebersole shooting a free throw about 90%. All right?
What are the percentages we've got this year?
You looked it up before, so you just play it in class. You got on the Womack website.
It's not that bad.
I shouldn't say anything because my son, who's a little wimp apparently, he can probably shoot free throws almost as good as I can until it comes game time. Then he can't make a one. Is that you, Jenna?
I am 66% from the free throw line.
When I used to coach basketball my first couple years of teaching, I gave my players a choice of, we'd shoot 10 free throws at the end of practice, and however many they missed out of the 10, they ran suicides at the end of practice.
I wish we did
What was the other
that.
choice?
And
70%.
the other choice was I would shoot them, and however many I made, they would run that many. Well, at first, they looked at me and they said, we're going to let you shoot them.
You made 10.
So I made 10.
So.
Then they thought it was a fluke, so they had me the next practice do the same thing. And I probably made like 8 or 9 or something. And then after that, they started shooting because it wasn't.
I would give up on that too then. I feel all running.
Get that. You have to shoot 80%.
So, notation for a binomial experiment, N stands for the number of trials. Again, when you write this down, I shorten it up, make it something that's going to make sense to you. P is the probability of a success. This is how many trials, number of trials. So these are just the letters and stuff that get used. Q, stupid thing. Q is the probability of a failure. And X is the random variable. Whatever it is. If you're shooting free throws and we're shooting 10 of them, then it might be like 6. The chance of making 6 out of 10 or 7 out of 10 or whatever it is.
Is Valley View good this year?
Are they now?
Know that these two,
Oh, your son plays right. Yeah, we played him this year.
these two are complements of each other. They're complements of each other. So that means together they have to add up to one whole. So if the probability of me shooting a free throw and making it is 75%, what's the probability of me missing?
25.
25. So they're complements of each other every time.
How's the Ferguson kid?
What?
How's the Ferguson kid?
I don't stay and watch varsity. My kid doesn't play varsity very much. So.
We're not missing much not coming here either.
I meant to come here a couple of times. I had tickets and everything printed out. Those things came off.
Probably missing each other.
Decide whether the experiment's binomial experiment. If it is, specify the values of N, P, and Q. Very important that you can pick out these values. When we get to the end, the stuff at the very end that I said is going to be on the exam, very important that you can pick out those 3 things. A certain surgical procedure has an 85% chance of a success. A doctor performs the procedure on 8 patients. The random variable represents the number of successful surgeries. What's N this time? How many trials are we doing here?
8.
8. So N is 8, good. P is the probability of a successful surgery, so 85 or 0.85. And then Q would be what?
15.
Do you want us to turn them in decimals, or can we leave this percent?
You're going to need to turn them into decimals because we're going to have to do some kind of math with them, and you can't do math with the percentages. The thing they didn't ask you to find, they didn't ask you to find X. If we were going to find X, what it would be, X is like your sample space. So if if his doctor is performing this surgery 8 times, what could happen? What could X be?
Could be 8.
Could be 8.
7, 6, 5, 4, 3, 2, 1, 0.
So that's like our sample space. That's all our different X's. All right? They didn't ask us to find that part here. They just asked us to find N, P, and Q. But that it could be that.
So X would be like our sample spaces, or whatever.
Yeah. I shouldn't have said it that way. All of the X's are like our sample space. When we do it, we're going to pick out like one of them to be our X. That's our certain variable that we're dealing with. Like maybe we want to find out what's the probability that this doctor did the surgery and 6 of them were successful. Or maybe we wanted to do something like they did the surgery and we want to know 6 or more were successful. And we're going to find that probability. That's all that stuff. That's everything. A jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles. Is this a binomial experiment? Does it have just a success and a failure?
No.
No.
2 possible outcomes?
No.
None. Now, it could, if we wanted to set it up that way,
If you worded it.
we could say that blue and green are both failures and red is a success, but the way they got it here, it's not binomial. And, I forgot, they weren't replacing it. So they weren't replacing it, so is it gonna work out that every draw is the same probability of drawing it?
No, they
That
are.
changes, so that makes it not a binomial also. Binomial probability formula, I'll give you a second, write down this formula, this is what each thing stands for. As you write it down, know these little subscripts? What's C stand for again?
Combinations.
Combination, so N and X there, X to an exponent there, N minus X there. This is just the way it would be if it's expanded on out.
So would the P still be?
P is a little p, so it's not permutations.
Wait.
Can you see that, Jenna?
Yeah, I was just about to ask a question. No, I was about to ask the same question Michael did with the P.
Because I can't see the little letters from here.
I do if I open my eyes really wide. Okay. Ready.
probability here to find if probability of a success is P. To find a failure, we just take 1 minus whatever this is.
Hopefully I don't knock your eye again and it come out.
So these equations
Isaac,
confuse
did you
me.
see me?
By doing that right there.
You were laughing, you were like, cool.
It was funny.
I was just trying to make sure, because I didn't know what, something fell out.
Did it hit hard? I thought it just was a little.
No, I just like bounced.
And what it says down here at the bottom, you're just taking out the R and putting X in its place, whatever your X value is. Whatever goes here, whichever you're picking from your sample space there. This stuff, and we're gonna use I'm not gonna lie to you today, we're gonna use our calculator for a lot of this. But don't make this formula any harder than it is, because your calculator will still do a lot of it. And actually, it might be easier. Well, it would be easier if we're using the formula just to do this, because you can punch this first part, the combination part, right into your calculator, then just hit times this, second, the third part. We'll do something with it here in a second. Microfracture knee surgery has a 75% chance of success on patients with degenerative knees. The surgery is performed on 3 patients. Find the probability of the surgery being successful on exactly 2 patients.
You got a Band-Aid. I mean, like, it's not bleeding, but like, you put pressure on something to make it stop hurting. That's what I want the Band-Aid.
So we have this. We could draw a tree diagram for this. That's what I did here. Draw this tree diagram for it. Find all the successes. They said they wanted, if I go back to it, find the probability of surgery being successful on exactly 2 patients. So we wanted on exactly 2. Well, if I make this tree diagram, I find the probabilities out here. And we want exactly 2 patients. Well, there was 2 successes there, 2 successes there, 2 there. What would I do with all these probabilities?
Divide it.
Add 'em.
You just add them all up. Here I multiplied them because they were all the same, so it was just 3 times that, but I could just add them all up. And that would give me the probability that exactly 2 surgeries come out successful out of the 3.
Is that the only way to find that, is like a tree diagram?
So we could use the formula, and that's what this next part's gonna do. I was hoping it didn't show all this, but it does. So our N is 3. That's how many surgeries we're doing. The probability of a surgery being successful was 0.75, which is 3/4. I'm not sure why. I probably copied this off somebody else. So they changed it to 3/4 instead of 0.75. If probability of being a successful surgery is 0.75, then probability of a failure is 0.25.
Better than 0.24.
And this time we want our X. That's what we're looking at, is we want 2 successful surgeries. So that's our X. And if I plug into the formula, this is that formula right here. It's just C N X P to the X times, what was it, Q to the, look at your formula
Q
there.
to the N minus X.
N minus X. So in place of N, we stick in 3. 2 this time. Our probability is 0.75, right? And X, we want 2 times
0.25.
Q, why'd I put Q? Times 0.25,
2.
3 minus 2, which is 1.
So will they always give us N?
Yeah.
That's clutch.
So they're always gonna give you
N and X?
all of these numbers. The only one they don't give you is Q, but we find that by subtracting 1 minus whatever P is. Now, I could be lying to you, and they could give you Q and not give you P, and you just do the same thing to find P, subtract from 1. And once you did that, they did all this out mathematically. You could punch all of this just this way into your calculator. If I was punching this into my calculator, type that in first, then hit equals, and then hit times, and then put in 0.75 squared times 0.25. Do we really need to raise that 0.25 to the first power?
Just 0.25.
Just 0.25. If it's just to the first power, it doesn't do anything. So the probability of this doctor doing 3 surgeries and exactly 2 of them being successful is about 42% of the time. That exactly 2 of them are going to be successful. That doesn't sound great, but you've got to remember what that's saying. It's saying exactly 2. There's going to be some times where all 3 of them were successful, and then sometimes when 1 or 0 were successful, and we're not looking at those, we're just looking at exactly 2.
So like that equation comes out to be that.
Right.
Okay.
This is the same thing as this says, only I put mine in decimals, and
Yeah.
they use fractions. Exact same thing.
Okay, then, so like, if you go back to the chart, how did like, number of successes was 2, right? And they wanted 2 successes out of 3, so we're finding that.
Right, so
Okay.
if I was making the tree diagram, I would do this. First surgery could be a success, could be a failure, right? If the first surgery is a success, the second one could be success or failure. First one was a failure, second one could be a success or a failure. Third surgery, success, failure, success, failure, success, failure, success, failure. Right? Now, to list these out, if I look at this top one, to list out my sample space out here,
Yeah. Yeah, and you get all those
be
outcomes.
S, S, S,
SSF,
S, S, F,
SFS, so on and so on. So are we trying to find like what's it called, like for like 2 successes out of the whole thing?
right, what percentage of the time,
Well, 2 out of the.
what's the probability that it's gonna
2
be 2 out of the
Okay.
3? So then, once we're looking at this, what they did here to find the probability of 3 successes was 0.75 times 0.75 times 0.75. So they found the probability of each of these things occurring. Probability of 2 successes here for this second one would have been 0.75 times 0.75 times failure is 0.25. And they did it all in fraction form instead of decimal. And all they did, once we found all that, we add all 3 of those up. So 9 over 64 plus 9 over 64 plus 9 over 64. This is a long drawn out way to do it compared to just using the formula. We get the same answer.
We can use fractions, right? Because that makes more sense to me. I don't know why.
Does the fraction, yeah.
If it's like numbers like that, it makes
Yeah,
more
if it's
sense.
75% or 0.25, then, yeah, then you could use the fractions and do it that way. The only bad thing with fractions is, when you're punching something like this into your calculator with a fraction, you gotta make sure you use the parentheses, otherwise
We'll mess it up.
the calculator doesn't understand it. The results of a certain survey indicate that 67% of U.S. adults consider air conditioning a necessity. If 100 adults are randomly selected, what is the probability? Exactly 75, so we want exactly 75, considered it a necessity. So if we went out and we picked out a random 100 adults what's the probability that exactly 75 of them said it is a necessity? N, how many are we picking?
100.
100, so that's our N. What's the probability?
60.
67, so 0.67.
Well, I thought.
What's our Q? We'll skip the X.
It's 33.
Wait, I thought P was your success.
It is.
67% of adults consider it
Oh, oh,
necessary.
oh.
And that's what we're trying to do. And that might be a hard thing sometimes. You gotta decide success, failure, because we're considering a success here, the fact that they consider it a necessity. Whether that's a success or not, doesn't really matter. We could consider it a failure. So these two could actually be switched around, and it shouldn't make a whole lot of difference. We want X to be what this time? How many? 75. Now, X could be 0, 1, 2, 3, 4, all the way up to 100, but we're looking at just X being 75. So we're finding the probability that 75 out of that 100 said it's a necessity. Oops, thought previous. Let's go back here. So we're going to use that formula. I thought they'd done it for me again. We're going to use that formula. C, what was N?
100.
X
75.
times P was 0.67. And that's raised to what power?
70.
The X, is that right?
Yeah, 75.
Times Q, whatever, Q again.
0.33
0.33.
raised to the 100 minus 75.
100 minus 75, which is 25. And if you punch that into your calculator, again, the way I punch it into my calculator, if you're following along right now and doing it on your calculator, type in 100, go to the math button and over to probability, so you can get to the NCR. Go down to NCR, type it in, and put in 75, and then I would hit equals, and it gives you some crazy scientific notation number.
I got 0.020.
I got 0. Oh, because I put 10.
I got 2.4 times 10 to the 23rd.
Yeah, that's what I got.
What did I do?
Does that say 0.33?
You got time, don't times it.
Oh.
So, yeah. So again, just type in this part first.
I got 0.00.
'Cause Because the calculator's not going to understand, if you type in all the rest of it, the calculator's not going to understand what you're saying. So just type in that part, 100, go to math, go over to probability down to NCR, then 75, and hit equals.
Okay,
Then you got 0.2.
yeah. No.
2. I meant answer. I meant whole answer.
Oh, the final answer.
Yeah.
So now, once I have that answer on my calculator, now I'm going to times it by, so now I'm going to hit times 0.67, and I'm going to use the little caret buttons. Everybody know what I'm talking about when I said the little caret button?
Upwards, isn't it?
That little thing like that. The little caret button that's right above the division sign. And then 75. And then I'm going to hit equals again.
Alright.
Then, so I'm typing it in. I type in this, hit equals, type in this, hit equals. Then I'm just going to hit times, and then I'm going to type in this last part. 0.33, little caret button, and then 25, and hit equals. And what did it come out to be? 0.0201. Is that right?
Yeah.
So, about what percent of the time are we going to expect that exactly 75 people say it's a necessity?
2%.
About 2% of the time.
Dad always makes fun of me because he said they didn't have air conditioning. I always complain about it being hot.
We never had air conditioning.
Caleb Miller still does it. They have like one thing. It's brutal on that.
A binomial probability distribution lists the possible values of x. This is if we have to do this out longhand. So I'm going to show you this, then I'm going to show you, hopefully, how to do it on the calculator. So a probability distribution is this. That's what we did last time. Looks like that. Ours, I always write them up and down. I don't know why this book switches and goes side to side now. I write mine up and down. So this went back to the knee surgeries. Probability of getting 0 successful ones is that. Probability of 1 successful one, 2 successful ones, 3 successful ones. That's what the probability distribution looks like, and it's considered a binomial this time because it's either a success or a failure. We can use that formula to find each of these numbers. That's what we were just doing. We found, what did we find? We found this one, didn't we? Probability of 2 successful.
Yeah.
And again, what we could do with that is we could find the probabilities of stuff like on that last test, what did it say? Probability that it rained or that it didn't rain at least one of the days. So we could find the probability that at least one surgery is successful. Well, we're not looking at just this number. We don't want exactly one surgery. It says at least one. So we want all 3 of these. What do you think we do with these 3 probabilities?
Add 'em up.
Just add them up.
You should have the 100 or close to 100.
All it should be, and we could just say 1 minus this, and it should give us what those 3 added up to. Or we could say we want the probability that the doctor doesn't get all 3. Well, then we could add up these 3 to get that, and so on and so on. It doesn't look like it helps a whole lot here. But if the doctor did 1,000 surgeries, we probably don't want to make that whole list and then add them all up or subtract them all from 1 or any of that stuff. In a survey, workers in the U.S. were asked to name their expected sources of retirement income. 7 workers who participated in the survey were randomly selected and asked whether they expect to rely on Social Security for retirement income. Create a binomial probability distribution for the number of workers who responded yes. So we looked through this, and I can't hardly read this, but I think Social Security's right here, isn't it?
Yeah.
So what's the probability that they said that they're going to rely on Social Security?
25%.
So 0.25. We're going to consider all the rest of this stuff as a failure, right? Or as them saying no, because these other people have other ways that they're going to plan on retiring or using money, what money they're going to use for retirement. So 25% said yes to Social Security. What percent is going to say no?
75.
So that would be our Q. And what it say? We find our N here. What did it say? How many people were?
7.
7.
7 big ones. It's cold.
What am I want to count?
What they expected to create binomial. So N is our 7. They didn't tell us which X we want or anything. So N is 7, P is 0.25, Q is 0.75, X 0 through 7. We do all of this. Probability that X is 0
Whoa.
is this. Probability that X is 1 is that. X is 2. And this is just for 7.
What the?
Right? So if we would have said we want to pick 50 random workers, you'd have to do one for each one of those. You'd have to do that formula for each one. So that's quite a bit. Let's look at this one just real quick. Does anybody know what anything to the 0 power is again? It's 1, so just to make sure you remember that.
And if it's the number, like if it's 7, then 7 is 1, right? Like tell the combination
Wait,
7
so that would make
there.
that whole answer be 1.
If it was this.
I just had to
Don't be trying to use the 0 rule for 1.
Yeah,
That
I
doesn't
know.
work.
I don't know.
Wait a minute, I just said a stupid thing.
So our probability distribution would look like this. And again, if we wanted to find what's the probability that 4 out of the 7 said yes to Social Security, we just look right here. If we wanted to find the probability that 3 or more said yes, then we take all these probabilities and add them up. A survey indicates that 41% of women in the U.S. consider reading their favorite leisure time activity. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time activity. Find the probability that at least 2 of the women responded yes. So this time it says at least 2 of them. So we want the probability this time that's 2 or more. So what that would be, that'd be the probability that's 2 plus the probability that's 3 plus the probability that's 4. This time, what's our N this time?
4.
Our probability is,
41.
what's our Q then?
50.
And our X's, if we wanted to list out our X's would just be 0, 1, 2, 3, or 4. So we'd want to find the sum of all 3 of those that we said there. We do the formula for each one. For P is 2, P is 3, P is 4, and then we're just going to add them all up. The probability that at least 2 women out of the 4 say that reading is their favorite leisure time activity is about 54%. Let's do this a little bit. Same idea on this one. So we have this, and again, the ones I picked to put on here, all sort of short. Oh, this one was a histogram. Hint, hint, on the final, or on the semester exam, you're gonna have to make a histogram for something. So make sure you remember how to do that. This one's a histogram, but it's for the probability, so the probability's on the side over here, then you got this.
Can I borrow a ruler?
You'll be all right.
I can't draw. You're not gonna be able to tell.
Write this down. Instead of us doing all this, especially when the list gets long, a lot longer than anything I put on here, we can do this. And we're gonna try some of this on our calculator here in a second to see if we get the right answer.
Is there?
Is that where number 5 is supposed to be?
Yeah, this is, I'm not sure why this is red. Probably just because I didn't know what I was doing. Number 2, you get that. It's, that's where it's at.
I just didn't know what it was supposed to be.
On the calculator, it's probably blue or whatever. So first thing I do is I hit second, and then I'm gonna hit the bars button. Oh, that's what it is. This is what the actual button says. This is the part that's above it that you're gonna get to when you hit the second.
The button is, okay.
Hit that first.
Yeah, I should have put that first, shouldn't I? So you're gonna hit second. Bars is actually what it says, but when we hit second, we're actually going to that VISTR there.
What do we put for 5?
It's just a parenthesis.
Alright, it's on.
The close the parenthesis.
Okay, so the second area, insert, and then you go to 0. Oh, yeah, the binary. 5, okay, yeah, so.
This is, once you get second, and then you hit this,
NPX,
It's-
which is not yet.
it says 0,
Yeah.
and it also says binomial PDF.
And then close parentheses. Okay.
When would your exam be?
I don't remember.
Thursday?
Thursday.
No, yeah, Thursday.
So what day is Wednesday? What classes are those?
Round
No,
two
it
through
shouldn't.
four.
Which Wednesday is?
No.
March 2 through 4 and Fridays. I don't remember which ones.
No, yours is.
I don't think so.
So if I have all that?
No, because we're in, rewards or something.
Oh, okay.
All right, so if we do this, the survey indicates that 41% of women, grab your calculator so you make sure that we can do this. Reading is their favorite activity, you ask them, and you wanted at least 2. I can't remember what we came up with. Anybody remember what the answer was when we looked at before?
Nope.
No.
Oh my gosh.
Let's go back and see here.
I don't know if we did this one.
Yeah, I think we did.
So at least 2, it was 0.542. So again, what's our N this time?
N is, how many women are there?
4.
How he deals with them.
What's our P?
41.
41%.
So 0.41. Q is,
59.59. Okay, so.
so on our calculator, this is what you're gonna do on your calculator. Second, bars, very first one, mine says 1, not 0. Did your guys just say 1?
Mine says
Mine
one.
says 1, but 0's up underneath 9.
Oh, yeah, because we're doing binomials, aren't we?
Yeah.
Sorry, my fault. I was looking at normal. That's something that we got coming up later.
Do we multiply this?
So we want to go down to 0, binomial PDF, hit enter, and it said to put in what?
NP.
NPX.
And it wanted commas in between them, right?
Yep.
So 4, comma, 0.41, comma, 0.59, and then you're going to close the parenthesis.
Error domain, quit or go to. Got it.
So either you messed up on a comma somewhere or parenthesis.
Where does the 0
Is that like
at?
grade school?
It's down. You gotta go down past 9.
Oh, right here.
Oh, you want us to do this, okay, that's
That's
right.
like my tracker.
So, 4,
We put in the wrong numbers, that's why it's not working. What numbers did it tell you to put in? You guys lied to me.
NPX.
NPX.
Yeah.
What's our X this time?
Oh, that's why.
We don't want Q. What's our X?
1, 2.
2, right? Because we're looking at 2 women. So we hit second, vars, go down to 0, enter. It's binomial PDF. We put in N, which is 4, comma, P, which is 0.41, comma, X, which is 2, close the parenthesis.
Okay, 0.35.
Now it gives us this. Gives us that. That wasn't our answer, was it?
No.
What did we just find?
But we didn't include, we found a success.
We found the probability that it was
Successful, or 2.
just 2.
Okay.
We still need the probability of, oops,
3, 4.
what was it, 2 or more, right?
Yeah.
3, and the probability that it's
4.
4. So that's for 2. To do all the rest of these, now just listen for a second. To do all the rest of these, we'd have to do the same thing, but punch in 3, punch in 4, write down those answers, then add them all up. Now, on your calculator, if we want something like this, if we want 2, 3, 4, all the way up, go back, hit second, vars again, go down to the 0, and actually go past it. Instead of binomial PDF, it says CDF. CDF means cumulative. That means it's adding up everything. All right? So let's type that one in and see what we get. So hit, on mine it's letter A. I don't know what it is on your guys'.
Mine was A2.
And then put in our N, P, and X. So put in 4, comma, 0.41, comma, and 2. And close the parentheses.
0.809.
Is that what we got the other time? We got like 0.54, didn't we?
Yeah.
Wonder what's going on here. So, what this is telling you, the binomial PDF on your calculator just gives you one answer, or one answer. So it's just, if we wanted for like just 2, if we just wanted the probability for 2 women, then we use binomial PDF. Binomial CDF listen, because this is messed up later on in the class with something else. Binomial CDF trying to remember for sure how to tell you so I don't mess you up.
Christmas vacation. I'm very frozen. Yeah, and Monday is pajama day as well.
How does that make sense?
It's PJ Day part 2 on Monday.
Wait, so tomorrow is Christmas day.
Yeah. And then Monday is.
So if I wear a reindeer suit tomorrow, and nobody else dresses in their PJs, I'm gonna be so
I'm
mad.
wearing my pajamas. Me and Jenna have frosted pajamas.
You better send me a picture of you in your pajamas.
Yeah.
because I am not.
Hey, easy, man.
You wake up at like 4:30. I wake
Very
up
true.
at 6:40.
Very true. Makes it easy.
So bring a pair of clothes and you're gonna pay. She's gonna pay you.
Who is? You didn't want to go to the dentist? Why?
When I last went like 7.
Oh, dang it. Forgot to close today.
I hate snow.
Sorry, what are you saying? I can't-
Type this into your calculator.
Such-
Hit second, vars. Go down to binomial CDF.
Speed.
Hit enter. And we're going to put in N, which is 4, P, which is 0.41. Now, what we want this time, we're looking at, our possible outcomes are 0, 1, 2, 3, and 4. All right? We want to add up 2, 3, and 4, correct?
Yeah.
But our calculator is dumb, and they,
Being goofy.
instead of, for this one, instead of adding up the ones higher than it, it adds up the ones lower than it. So what we want to do, we have these are possible outcomes. 0, 1, 2, 3, and 4. Now listen this closely because it's going to confuse you. And again, something later on in the class is going to be just the opposite of this. These are the 3 that we want. But the calculator doesn't understand going up. But we can find these and then subtract it from what? What's the whole thing?
0.809.
1.
Subtract it from 1. And that's going to leave us with these 3.
Cooper.
So if you type in 4, binomial CDF, 4.41, and 1, that's telling the calculator to start at 1 and add up everything down. Close the parenthesis, hit enter. What'd you come up with?
0.457 or 0.58.
4, 5, 7.
Oh, if you round.
We're going to subtract that as an 8.
Yeah, because if you round.
We're going to subtract that from 1. What's 1 minus 0.458?
0.452, which is what we
No way.
So for binomial CDF, write this down somewhere there on your paper. Binomial CDF goes from the x that you put in down and adds them all. So instead of having to go through and find all 3 of these separately and then add them all up, which you could do. So if I just confuse the heck out of Jenna and she wants to go through and find this one, this one, this one, just by using the binomial PDF, go right ahead. Then at the end you just have to add them all up. If your probability, this is just something real quick, if your probability is greater than 0.5, greater than a half, then your histogram should be skewed to the left. That'd be like this. If the probability is less than a half, then it should be skewed to the right. If your probability of whatever it is that you're looking at is exactly 0.5, then it should be symmetric. And the only reason I stuck this one on there was because those are the 4 that we dealt with earlier this year. So probability is greater than 0.5. It's going to have the bigger stacks over here to the right. If probability is less than 0.5, the bigger stacks are going to be to the left. And if probability is exactly 0.5, the bigger stacks are going to be in the middle when you have a histogram. This is very important.
Okay, brushing up everything.
For a binomial setup, instead of using all those formulas, those big long formulas that we had 2 classes ago, for a binomial setup, to find the mean, variance, and standard deviation, you can just use these 3 short formulas. You can still use those other formulas, and they'll still work. They're just longer.
What is it for variance, use multiply all of them?
Now, these 3 formulas only work if it's a binomial distribution. They only work for binomials. So these formulas will not work for all that stuff that we did the first time. All right? In the other section, 2 classes ago.
So we pretty much, we pretty much just wrote this for nothing.
No. Because this is just finding mean, variance, and standard deviation. It's
And
not,
this is answering, okay.
it's not finding the probability. So to find the mean of a binomial distribution, again, next week, find the mean of a binomial distribution, n times p. That's all you got to do. That's going to tell you the mean. Remember, the mean is the expected value also. That's what you expect to happen. To find the variance, n times p times q. And then standard deviation, we just take that and we take the square root. And that's going to be your standard deviation, your sigma.
Simple, easy.
So if you're not sure it's a binomial, use the formulas from the first section that we did 2 classes ago. All right? Because they'll work for everything. If you're sure it's a binomial, then use these simple formulas. If they're asking you to find the mean, variance, and standard deviation. If they're asking you to find the probability of something, this doesn't help. Pittsburgh, Pennsylvania, about 56% of the days of the year it's cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Interpret the results and determine any unusual values. So on this, our P is 56%, so 0.56. How many days are in June?
30,
30, 30,
28, I don't say about July.
30,
Oh,
Steph, 30.
30.
30?
What is that? What were you just doing?
You never learned that in kindergarten?
Every other month is,
January, February, March, April, May, June. It's like 31, 30.
except for February, February.
Yeah.
February's what?
28.
So this is 30, this is 31.
This is 31.
And that was 31. This is 30.
Yeah.
What the heck, is that January?
So our N is 30 days. Our P is 0.56. If P is 0.56, what's Q?
You said P's 4 by 4.
0.56. Not sure why that door is not shut. Somebody's done something good. Be 0.44, you subtract it from 1. So to find the mean, N times P, 30 times 0.56, which is about 16.8. That's the mean, that's the expected value. Since this is a binomial, that's your expected value. Well, what's that telling us? What's that mean to this problem? What's that showing us in this problem? What do we expect?
16.8 days will be cloudy.
Okay, we probably wouldn't say 16.8 days, would we?
Yeah, so
We'd probably say 16 or 17 days are going to be cloudy. How many days are going to not be cloudy then?
17 minus 30.
14?
14 or 13, right? 13 or 14 days not cloudy. If we wanted to find the variance, then we take N times P times Q. So we just take 30 times 0.56 times 0.44. And if, once we get that answer, if we want to find the standard deviation, we just take the square root of it. When we came in and we punched those lists into our calculators, that's what we were finding, the mean, variance, and standard deviation. If it's a binomial, we don't have to do all that. We can just do those three formulas. So, on average, there's about 16.8 days, 16, 17 days that are cloudy. Standard deviation tells us that 2.7, so 2 to 3 days, it's going to switch up. So, maybe this June, there's 16 days. Next June, it might go up to 19 days. Go up 2 or 3, one way or the other, or go down 2 or 3. To be unusual, we'd be outside that. Remember, we said anything outside of 2 standard deviations is unusual. So if we go outside that, then it would be unusual. So if we had a month of June where there was 23 cloudy days, that would be an unusual month. Page 211.
Question mark, question mark, question mark.
Can't remember why I did this. I think we could let them pick what they wanted to do.
What time did you start at 6?
Like 11 or 7.
That's what I say about minutes. That's what our other games are. Yeah. Probably it's.
It's at 6:45.
They'll probably get there. Actually, yeah, they'll probably play until about 6:35. 6:30.
Is it only 2 quarters?
Yeah, the JV will probably play until about like 6:30, 6:35, depending on. Then we will probably won't start warming up until 6:40, I would say. It's probably gonna be like 6:45 instead of. Just depends on how long the.
All right, let's do that as the assignment. Page 211, 3 through 27, the odd.